Hi folks, this is going to be 6.1 for Algebra 2, Operations on Functions. This is actually being posted after 6.2 through 6.6, but this is actually a special request I received to go back to 6.1, and so here we go. Operations on functions. I'm going to actually give you several different functions. We're going to give you f of x is going to equal 3x squared plus 7x. Then I'm going to give you g of x. G of x is going to equal 2x squared minus x minus 1. Let's then give you h of x. H of x is going to equal 3x squared minus 2x plus 1. And then let's go k of x. K of x is going to equal x minus 4. So there are 4 functions right here. Again, a function is just, this can be replaced by y equals, but it kind of just shows you different functions as function notation. So we're going to do addition, subtraction, multiplication, division, and then composition of. So 5 items here. Let's first do addition. So we have addition. Okay, I'm going to add f plus g of x. So when I add f plus g of x, what this is saying is f of x plus g of x. And I'm going to just add those two functions. So I have 3x squared plus 7x plus 2x squared minus x minus 1. That is the equation I'm working with. So let's simplify that. Well, when I have a plus right there, everything just comes out as it is. So I'm actually going to have to rewrite that whole expression, plus 2x squared minus x minus 1. And I find the like terms. 3 plus 2 is 5, so that's 5x squared. 7 minus 1x, there's an invisible 1 right there, is 6, so plus 6x. And then the minus 1 stays. And that is our most simplified answer for our addition problem. Okay, well, what if I have subtraction? Okay, subtraction. I'm actually going to do f minus g of x. So f minus g of x is going to go just plain old f of x minus g of x. So f of x minus g of x. That's where I'm getting it from. I take my f of x, 3x squared plus 7x, and I subtract my g of x. Now, most importantly here, I have to put g of x into parentheses. I actually did that in my addition just to get into the habit of it. But because subtraction is you have to distribute the negative, you have to make sure that that is in parentheses. Otherwise, you're going to be getting something wrong, and we don't want that. So 3x squared plus 7x minus 2x squared minus a negative is really plus x. And again, minus a negative is plus 1. So that is what that simplifies to. Let's fully simplify it. Find the like terms. 3 minus 2 is 1x squared. 7 plus x is going to be 8x. And we have a plus 1. And there we go. All right. This time, let's go to multiplication. So multiplication. All right. So with multiplication, I'm actually going to do, let's have us do h of x times k of x. So you're going to see h times k of x. What does this mean? This means h of x times k of x. So I am going to take my h of x and k of x, and I note that it's a trinomial. Oh, sorry, you can't see that. A trinomial multiplied by a binomial. Everyone who knows me knows I love the box method. So that is actually how I'm going to do it. I'm going to do the multiplication over here. So we have the box method right here. That is probably too skinny for my permanent marker. Oh no. So we're going to try that here. That is definitely going to be too skinny. I am not. Nope. We're going to redo that. Permanent markers are fat, guys. They are just so much. Okay. That's going to be much better. So let's try this out. We have an x and then minus 4, for that's our k of x. And our h of x is 3x squared, negative 2x, and a 1. If you're not familiar with the box method, what you do is both of these are multiplied together and their answer goes here. These are multiplied and the answer goes here. These are multiplied, answer goes here. Same for each row and column. Everything inside the box then at the end gets added up, and that's our final answer. So we have here 3x cubed. Over here, negative 12x squared. Over here, negative 2x squared. Over here, 8x. X and negative 4. So let's add all those together. We have a cubed one. Well, that's 3x cubed. As you'll also notice, I'm not going to circle them because my permanent marker is still a little bit too fat, but the diagonals all go together. So negative 12 minus 2 is a minus 14x squared. 8 plus x is plus 9x. And then our minus 4 stays. And that, folks, is our final answer. Okay, let's go. I'm just flipping my own notes over here. Let's go to division. So I'm actually going to kind of do like a little splitting this paper here. So hopefully you guys can see that. Okay, so I'm going to do division up here. Let's do division. And I'm going to do, actually, let's do h of x. So you're going to see an h divided by k of x. What this means is h of x divided by k of x. So if you remember that synthetic division we've been doing, yay, synthetic division. So we're going to do that long L right there. And then we have the opposite of what you have. So k of x, we have x minus 4. So we're going to put a 4 on the outside there. And on the inside here, leaving enough space for this right here, I'm going to have, let's go, we have a 3, a negative 2, and a 1. All right, we're going to bring down this 3. So the 3 comes down. Awesome. 3 times 4 is 12. All right, 12 plus negative 2 is 10. 10 times 4 is 40. 40 plus 1 is 41. So our remainder, we're going to draw a line right there. Remainder's right there. We start with, again, we started with an x squared, so we start with 1 less than what we started with. Our answer is 3x plus 10 plus, we have a remainder of 41 over x minus 4. I also want to note that here, because it's a rational expression, well, x cannot equal 4 because we cannot have 0 in the denominator. Thus, this is our answer right there. Okay, our last part right here, and I'm actually just going to draw another line. Sorry, hopefully you guys can see all my sections of the paper right here. Our last part of 6.1 and 6.2 should actually say, I think this is actually, yeah, no, this is just 6.1. I'm sorry. 6.1 is composition. So, composition. Now, composition functions. These are going to be denotated as, you're going to see, let's see, if I'm going to say f, let's go of, it's going to be an open circle. It's not multiplication. F of, I'm going to do something easy. Let's go of k. All right. F of k of x. That means f of k of x. So just as you would if this was f of 3, you would substitute in 3 for every time you saw an x in f of x. However, here we're actually going to have substitute k of x, which is x minus 4, in for every time you see x. So let's do this. We're going to have f of x is 3 times, instead of an x squared, we're going to have x minus 4 squared. That's k of x. I'm substituting in k of x for every time I see x in f of x, plus 7 times x minus 4. All right, so I'm going to keep this 3 on the outside here, and I'm going to do x minus 4 squared. If you want to actually see x minus 4 squared being done, I have an x minus 4 times x minus 4. And I'm just going to FOIL that. I'm kind of doing it in my head a little bit, but I have x squared minus 4x minus 4x. So that's a minus 8x. And then plus, because it's a minus, negative 4 times negative 4, so plus 16. And then I'm going to distribute my 7 plus 7x minus 28. And I'm going to continue simplifying until everything I have a final answer. I have 3x squared minus 24x plus, that's 48 right there, plus 7x minus 28. All right. So, looking here, we have to find our commonalities, or our like terms. 3x squared is going to stay. It's the only x squared term. All right, our x terms. We have negative 24 and 7, and that is a negative 17x. And we have a 48 and 28, which is a 20. And that is f of k of x. All right. 6.1.